Okay, so this is a continuation of integrals part 2, day number 1. We're going to talk about turn the knob method. So if I were to be right-handed, which I am, and turn the knob, right, clockwise, and an indicator that I want to use the turn the knob method is that the exponent of the numerator is 1 or more greater than the denominator. Right? So I see x cubed over x squared. It looks like it could potentially be, arctan, right? I see a 1 plus x squared in the denominator, but I can't take out a variable. I can't pull that out like I could pull out a 7 or some kind of constant. So what you do is you turn the knob, placing this item inside and this item outside. So we take 1 plus x squared, and we're going to divide it into x cubed. Well, that's pretty nasty. That's pretty gross. Okay, so mathletes everywhere. How do we do long division? Carefully. We take the highest power on the outside, and we want to turn it into the highest power on the inside. So what would I multiply x squared by to get x cubed? X, okay. So I'm going to put an x over here, and I'm going to multiply through. I'm going to rearrange as I do it, x cubed plus x. Okay, now what do I do? Subtract. Okay, so the x cubes, they go away. What happens to the x? Becomes negative x. Now that's my remainder. All right, that's my remainder. So I get x, which is this thing, and I get this x minus x over 1 plus x squared. Now, we just talked about all right, let's throw 6 into 712. All right? 1. Subtract. Drop down. 1. 6 goes into 1 once. Multiply through. Subtract. Drop down the 2. 6 goes into 52 8 times. Multiply through, I get 48. So I subtract, I get a remainder of 4/6, right? So I take whatever's left over, and I divide it by what I divided by, right? Okay, so now that I know that x cubed over 1 plus x squared comes out to be this thing, right? X minus x over 1 plus x squared, I can separate those two, and now I can integrate much easier. Now, you might not see it right away, but, well, what's the integral of x dx? 1/2 x squared minus the integral of this. Well, because the numerator has a degree of 1 less than the denominator, I can use u sub, right? If I use u sub, I'd set u equal to 1 plus x squared, so du would be 2x dx. But I only have an x dx, so I'm going to solve, making that x dx. Right, and then I'm going to plug it back in. Well, then I'm going to pull that constant 1/2 out, and I have x dx, which is half du, and I have 1 over u. Right, and the integral of 1 over u is natural log of x, or natural log of whatever u is. So the natural log of u, which is 1 plus x squared, plus c. So how do I know to use turn the knob? Turn the knob if numerator's power is 1 higher than the denominator. Adam. Blue, wouldn't that be a great integral to have to do? Yeah, why? Because I'd use u substitution. Would you? Yeah, I'd set u equal to sine x, and then I have 1 cosine x left over. So this really would just be an integral of u to the 5th du. Right? If I use u equals sine, du equals cosine, and it'd be easy, right? Then I'd get u to the 6th over 6 plus c, which is great, because then I get, what would that be? Sine 6th x over 6 plus c. But on the one over here on the left, I don't have that luxury, right? I don't have one single cosine left over. So we got to do some work. Okay, let's chat first here. Okay, so folks at home or on the World Wide Web that are watching this and helping me gain some money on YouTube, what we did was we took cosine and broke it down into cosine to the fourth times cosine. We take cosine to the fifth, we split it into cosine to the fourth times cosine x. That was our first idea. And then Austin, thank you very much, said, well, why not turn it into cosine squared and cosine squared? Because now we could turn that into 1 minus sine squared x times 1 minus sine squared x sine to the fifth x times cosine x dx. And this is what I would call the baby sister or the baby brother, right? That's going to end up being your du. We'll have our du over here. We'll take them to the park. We'll forget about them for a while, but then we will use them later on. Right? That's the little brother or sister. Was that dark? Some of you were that kid, so you're kind of offended by that. Okay, now I'm going to FOIL this. Let me FOIL this out. I get 1 minus 2 sine squared x plus sine to the fourth x cosine x dx. Did I do anything wrong foiling there? 2 squared. Okay, I think we're good. Now, what is this going to turn into? I'm going to turn it into 1, 2, 3 different integrals. And I know that this one will be a positive. So the first one will be a positive. It's going to be sine to the fifth x. Don't forget, we're going to distribute both of these terms to all three of these things. Minus, what would the next one be? Sine to what power? Sine to the seventh. I'm going to take the 2 out and put sine to the seventh x cosine x. Look at the little baby sister here, baby brother, baby sister. Thank you for following us along, so we didn't have to chase you down at the end of the day. They're like, you got my granola bars in your backpack. Well, I would not chase you. And the last one, we plus sine to the ninth x cosine x. So I'm going to say u equals sine x, so du equals cosine x dx. So this would be u to the fifth du minus 2 u to the seventh du plus u to the ninth du. So that's 1/6 u to the sixth minus 2/7, no, 2/8, which is 1/4 u to the eighth plus 1/10 u to the 10th plus c. 1/6 sine x to the sixth minus 1/4 sine x to the eighth plus 1/10 sine x to the 10th plus c. Don't forget plus c. Always bring Charlie along. Your cousin Charlie. All right.